Now next we will see how the velocity of a point on the link is calculated. Okay, again I am going to consider a link AB. The point A is having a displacement towards upward side, so obviously it will have the velocity towards the upward side. So VA is the velocity of point A. Similarly, for this link, point B is having displacement towards the right side. Horizontal displacement is there towards the right side, so obviously it will have the velocity towards the right side. So let us draw the velocity towards the right side. So VB is the velocity of point B towards the right side, VA is the velocity of point A towards the upward side. Okay, so for this particular link I am going to locate the instantaneous center. Then how to locate the instantaneous center? First of all, I will draw a perpendicular to the velocity VA towards the right side. So let us draw the perpendicular. So this is the perpendicular, and next I am going to draw the perpendicular to VB towards the downward side. So at the intersection point I will get the instantaneous center for the link AB for this particular position. For this particular position, I is the instantaneous center of link AB. Now how the velocity is actually calculated? We know that in the relative velocity method we used to take a fixed point. So similarly we can see that I'm going to take the fixed point here. O is the fixed point I have located at here. Now I am going to draw a velocity vector of magnitude equals to VA towards the upward side, and a velocity vector of magnitude equals to VB towards the right side. Which one will be horizontal? Well, let us draw. So this is the velocity vector VA, which is going to represent the velocity of A relative to O, because the point A moves towards the upward side. So this is the vector OA, which is representing the velocity of point A with respect to O. O is the fixed point. Okay. Velocity of B with respect to O, it will be towards the right side. Okay, I am going to draw a vector of magnitude equals to VB. So OB is the vector which is representing the velocity of point B with respect to fixed point. Okay. If we join the point A and point B by this, so here we can see that the vector AB, it is actually representing the velocity of link AB, and here we can observe that the vector AB is perpendicular to link AB. Here you can see that the link AB is having geometry like this, and vector AB is exactly perpendicular to link AB. So this triangle represents the velocity vector diagram by relative velocity method. So here I am going to draw, I am going to tell the method of calculating the velocity by instantaneous center method. So here we can see that alpha is the angle made by the velocity vector VA with the link, and beta is the angle made by the velocity vector VB with the same link, or with the axis of the link. Okay, so here in triangle ABI, this angle is 90 minus, this angle will be 90 minus alpha, and this angle will be 90 minus beta. Okay, because this one is beta and this one is alpha. So here in triangle ABI, this one is 90 minus alpha, this one is 90 minus beta, this one is 90 degree. Okay. So now I am going to resolve the velocity of VA along AB and velocity of VB along VB. So as we can see that this one will be the right angle triangle. Similar, this one is also a right angle triangle. If you join these two, here you will get the right angle triangle. If you will draw a perpendicular, here you will get a right angle triangle. So this is the adjacent side for the link, for the triangle. This one is the adjacent side, this one is also adjacent side. For the velocity vector VA, this one will be the adjacent side, VA cos alpha, and for velocity vector VB, this one will be VB cos alpha. So both the vectors VA cos alpha and VB cos beta will have the same magnitude. So that is why VA cos alpha is equals to VB cos alpha. Again, let us consider a triangle ABI. In the triangle ABI, I am going to apply the Lami's theorem. So in triangle ABI, AI is the instantaneous radius divided by opposite sine of opposite angle, sine of 90 minus beta, and BI upon sine of 90 minus alpha, because the opposite angle of BI is this one. So this is according to the Lami's theorem. So this one will be AI upon BI is equals to sine of 90 minus alpha divided by sine of sine of 90 minus beta divided by sine of 90 minus alpha. Okay. So here we have found the values of AI, that is instantaneous radius, and IB, instantaneous radius for the velocity vector VB. BI. Here VA upon VB will be cos of beta divided by cos of alpha. As we know that sine of 90 minus theta is actually cos theta. So I have written this in the manner of cos of beta is equals to sine of 90 minus beta, and cos of alpha is equals to sine of 90 minus alpha. This is because sine of 90 minus theta is equals to cos theta. Okay. So already we have calculated the values of sine of 90 minus beta and sine of 90 minus alpha. Here sine of 90 minus beta, a ratio of sine of 90 minus beta and sine of 90 minus alpha is AI upon BI. So VA upon VB is equals to AI upon BI. VA upon VB is equals to AI upon BI. So AI is actually, AI and BI are the instantaneous radius, and VA and VB are actually the velocity vectors. So we can calculate the velocity by using the formula VA upon AI is equals to VB upon BI is equals to omega. Omega is nothing but the angular velocity of link A. So this, by using this method, we can calculate the velocity of point A and velocity of point B. Only we have to, instead of using the length of link, we need to measure the radius, instantaneous radius, which is AI and BI. We need to measure the instantaneous radius. We should have the value of omega, then and only then we can calculate VA and VB, because that will be calculated by using the formula VA is equals to R means AI into omega, VB is equals to R into omega means VB is equals to R is nothing but BI into omega. Now let us see how the number of instantaneous centers in the mechanism are identified. There is a mathematical expression for number of instantaneous centers. Here we can see that n is equals to n into bracket n minus 1 divided by 2, where capital N is representing the total number of instantaneous centers, small n is representing the number of links. Okay, so let us see how the instantaneous centers are calculated. Before that, let us discuss about the types of instantaneous center. There are three types of instantaneous center. First one is the fixed instantaneous center, second one is the permanent instantaneous center, and third one is the neither fixed nor permanent instantaneous centers. Let us take the example of a 4-bar chain. Here you can see that this is the 4-bar chain. Link 1 is the fixed one. I have represented it by red color. It will not have any kind of motion. Okay. So let us apply the formula of calculating instantaneous center. N is equals to n into bracket n minus 1 divided by 2. So here total number of links are 4. If you put the value of n is equals to small n is equals to 4 in this given formula, you will get total number of instantaneous centers 6. Now we are going to locate the instantaneous center for this mechanism. So first we have identified how many instantaneous centers are there. There are total 6 instantaneous centers for the 4-bar mechanism. So let us locate the instantaneous centers. To locate the instantaneous center, first we need to draw a circle. So let us draw a circle. For this circle, after drawing the circle, we need to plot the points equal to the number of links. Here total number of links are 4. So I am going to divide the circle in 4 parts. Obviously at an angle of 45 degree you can take 4 points. So I am going to take the 4 points. First point is 1, which represents the link 1. Second point, it represents the link 2. Third point, it represents the link 3. And fourth point, it represents the link 4. Okay. Now what is the possibility of formulating the instantaneous center between link 1 and 2? Let us join link 1 and 2 by a straight line. So I12, here you can see that between link 1 and link 2 there is a one instantaneous center which is called as I12. Here you can see that when we will join the line A1 and 2 we will get I12. Let us join line 2 and 3. For link 2 and between link 2 and link 3 there is a connection. We can see that link 2 and link 3 is having some sort of pin joint. Here you will get second instantaneous center, that is I23, which is the instantaneous center between link 2 and link 3. For link 3 and link 4 we need to join line link point 3 and point 4 by a straight line, which is going to represent the third instantaneous here somewhere at here, link, which is the pin joint of link 3 and link 4. Okay, so I34 is the third instantaneous center, and for the link 1 and link 4 there should be a connection between link 1 and link 4. Obviously here we can see that the link 1 and link 4 are joined with each other by means of a pin joint. Okay, so here a fourth instantaneous center. So out of 6 instantaneous center we have positioned 4 instantaneous centers. Still 2 instantaneous centers are missing. So out of these 4, here we can observe that as the link 1 is fixed, it will not have any kind of relative motion. So I12 and I14 are the fixed instantaneous centers because they are not going to change their position. Similarly, here we can see that when you will rotate, if you will give the input to the link 2 in terms of a clockwise or anti-clockwise motion, the I23 and I34 are going to change their positions. Though these links are having a mechanical linkage, here a pin joint is there, here a pin joint is there, these are the permanent kind of joints. So these are the permanent instantaneous centers. I23 and I34 are the permanent instantaneous center, but they are going to change their position every time. As the link 2 moves, I23 and I34 are going to change their positions. Now still out of 6 we have located only 4 instantaneous centers, I12, I14, these are the 2 fixed instantaneous centers. I23, I34, these are the permanent instantaneous centers. Now third one is the neither fixed nor permanent instantaneous centers. We need to locate them. So 2 instantaneous centers still need to locate. So to locate the instantaneous centers, as we have seen that we have joined the lines 1, 2, 2, 3, 3, 4 and 1, 4. But whether there is any relation between link 2 and link 4 and link 1 and link 3, let us see. So I am going to draw a line which is joining link 2 and link 4, link 1 and link 3. So let us draw a line. First of all, I have joined the link 2 and link 4. Here we can see that 2, 4 is the diagonal of triangle 1, 2, 4 and 2, 3, 4. It is the diagonal shared by the 2 right angle triangles 1, 2, 4 and 2, 3, 4. So here we can see that actually 2 and 4 is the diagonal of 2 sides I12 and I14. So there is a relation of 2 and 4 with I12 and I14. So we need to first draw a line from I12 and I14. So let us draw a line. So here we can see that I12 and I14 are located on the same line. So we need to extend this line towards the left side. So let us extend this. So we have extended this line towards the left side. So again the same diagonal is shared by I23 and I34 for the triangle 2, 3, 4, right angle triangle 2, 3, 4. One side is I23 and second side is I34. So I23 and I34, these are the 2 permanent instantaneous centers. So I'm going to draw a line towards the left side unless and until it is going to intersect the previous one. So let us draw a line. We need to just extend the line link 3 or I23, I34 link towards the left side. So let us extend. So somewhere at here these two lines are intersecting. So this is nothing but the fifth instantaneous center, which is neither fixed nor permanent, between 2 and 4. This is I24 link. It is representing link 2 and link 4. I24 is the neither fixed nor permanent instantaneous center. Similarly, we need to locate the sixth instantaneous center. Yet we have identified 5 instantaneous centers. Here we can see that I12, I14 are the fixed one. I23, I34 are the permanent instantaneous centers, and I24 is the neither fixed nor permanent instantaneous center. Similarly, there should be a relation between link 1 and link 3. Let us join a line. Let us draw a line or a diagonal for the link 1 and link 3. So I have drawn a line. So here you can see that actually 1 and 3 is the diagonal of triangle 1, 4, 3 and 1, 2, 3. So here 1, 2 is representing I12, 2, 3 is representing I23. So the instantaneous center I12 and I23, this is the diagonal. So I am going to draw a line from I12 and I23. Here I12 is there and here I23 is there. So we need to extend this line towards the upward side. So let us extend the line towards the upward side of an unknown magnitude. Okay. Now the similar diagonal is shared by the the triangle I43. So I4 is nothing but instantaneous center I14 and 3,4 is nothing but instantaneous center I34. So here I14 is there and I34 is there. Here you can see that. So we need to extend the I14 to I34 line towards the upward side until it is going to intersect the previous line. So let us extend. So here we can see that we have got the intersection point for the link 1 and 3, so which is going to represent the sixth instantaneous center, which is also neither fixed nor permanent instantaneous center, which is I13. So here we have identified total 6 instantaneous centers. Out of that, I12, I14 are the fixed one because they will not leave their original position. They are fixed. I23 and I34 are going to change their position every time according to the position of link 2 and link 4 and link 3. Okay, so these are the permanent one. But I24 and I13 are the neither fixed nor permanent instantaneous centers because every time they are going to change their position. If suppose the link 2 will move towards the right side or it is going to trace a circle, then I24 will move towards the right side and I13 will be somewhere at here. Okay, so every time I24 and I13 are going to change their original position. So that is why they are called as a neither fixed nor permanent instantaneous centers. Okay, that's all for the today's lecture. For the next lecture, we will discuss how to calculate the velocity of every link by using this instantaneous center method. Okay, thank you.